Okay, here's a video for page 7, which is about Spearman's correlation coefficient, which is a new topic for applications and interpretation. So let me give you an example first. Let's say that you got two classmates who are talking about the greatest basketball players of all time, and they are comparing their rankings of these basketball players. So both the red student and the blue student have ranked Michael Jordan as number 1, and both have ranked Steph Curry as number 4. But as far as LeBron and Magic Johnson, they differ in their opinions. The red student has numbered LeBron as 2 and Magic as 3, and the blue student has reversed that order. So there is some agreement between them and some disagreement between them. If we graphed the red numbers as the x-axis and we graphed the blue numbers as the y-axis, it would look like what we have here. Okay, so we'd have the points 1, 1, 2, 3, 3, 2, and 4, 4. They kind of line up in a line, but since there is some disagreement between the red student and the blue student, they are not quite aligned. Right? Now, what if there was complete agreement between the students? Then we would have this list of points, 1, 1, 2, 2, 3, 3, 4, 4. Obviously, if I graphed this, end up with this graph, 1, 1, 2, 2, 3, 3, 4, 4. Complete agreement between the two classmates about the ranking, and those line up to form a perfect line. Now, of course, if I did stat calc lin reg on this, it would draw a perfect line between those two. Before I do that, remember that I do need to turn on the mode to see what the correlation coefficient is. The way I do that, if you've just reset your calculator, is I go into mode, and then I go probably to the second screen, and I go to where it says Stat Diagnostics, and I click that to on. And then now I do Stat Calc Lin Reg. So Stat Calc, and then Lin Reg is option 4, it's the first one. And then I press Calculate. And that gives me this line. And oops, I did the wrong set. So I did the first set. So in the first set, I would get a correlation coefficient of 0.8, right? If I wanted to graph the second set of data, which should give me a perfect correlation, then when I do stat calc lin reg, I'm going to do list 1 and list 3 because that's where I put those, okay? So I'm going to put stat edit lin reg, or stat calc lin reg, and I'm going to put in L1, L3, and that'll give me the second set of data. And that should give me an R value of 1. And it does. It gives me an R value of 1. Okay? So in this case, I get an R value of 1. In this case, I get an R value of less than 1. Okay? But it makes sense, right? Complete agreement would be R equals 1. Less than complete agreement would be somewhere between 0 and 1. Okay, so basically this is very similar to Pearson's correlation coefficient, which you already used with lin reg, but now instead all we do is we rank the data, and we're just checking to see if the rankings agree or not. And so instead of the regular R, now we use a notation R subscript S, and S stands for Spearman's. Of course, if we have a total disagreement, and let's say that we have in red we have 1 through 4, and in blue we have the complete opposite order, that would give us a Spearman's rank correlation coefficient of -1 instead of 1, similar to when we have a linear regression line which is perfectly diagonal in the wrong direction. Okay, that would be a -1. Okay, and of course 0 means no correlation at all. Alright, now let's go down and do this investigation. One more definition which they have up here is when you have data that is only increasing or only decreasing, they call it monotonic. Okay? mold is grown in 8 different petri dishes with different amounts of nutrients X, and the area of the dish covered in the mold after 48 hours, Y, is recorded. Okay. The results are given in the table and also shown in the graph. And this brings up a point. When do you use Spearman's correlation instead of Pearson's correlation? Well, look at this data here. This data obviously has some kind of correlation because if you look at it, it makes a very nice curve, right? Well, that's the key word, the curve. If the data makes a monotonic curve, so a constantly increasing or constantly decreasing curve, then it's probably not a good idea to use linear regression, because if you try to draw a line through it, it's not going to fit a curve, but it is a good candidate for Spearman's correlation. This is one of the times you would use it, okay? So in this particular case, we're going to write the rankings for the data here, and you could rank it from highest to lowest or lowest to highest. It doesn't really matter as long as you're consistent. Okay, so let's do that. We're going to take our X data and our Y data, and we're going to rank it from, say, smallest to largest. Okay, so it looks like this would be the smallest. This would be second smallest, third smallest, fourth smallest, fifth smallest, sixth smallest, seventh smallest, eighth smallest, right? And what about the other data, the Y data? So this would be smallest, second smallest, third smallest, fourth, fifth, sixth, seventh, and eighth. And if you're looking at the numbers, you can already see that they match up. But if we fill in the data table, which is right next to us here, we're going to see that for sure, because we're going to see that 6, 1, 2, 4, 3, 7, 8 in red is also going to match 6, 1, 2, 4, 3, 7, 8 in blue. So there's a perfect match, right? So if we did put 6, 1, 2, 4, 3, 7, 8 in list 1, and we put 6, 1, 2, 4, 3, 7, 8 in list 2, even though they're not in order here, it doesn't matter, right? If the data is lines up when you graph it, then we are going to see perfect correlation. So we already can tell that our Pearson's correlation coefficient, or in this case Spearman's, is going to be 1 in this case, positive 1, right? So we can put that it's positive 1 here. So comment on the result, relating it to the particular shape of the graph. So this is similar to when we comment on the R value for a linear regression problem. In this case, is it positive or negative? It's positive, right? Because in general it's going up, and it is perfect correlation because we did get a perfect value of 1 here, right? So it's positive and perfect, and in this case it is not linear though. It is perfect correlation in terms of the ranking. Okay? Alright, so let's go to some of these other problems. Let's look at the data given in 1A, 1B, 1C, and 1D. They're all in kind of different shapes. The important thing here is we are going to look at the ranks of each of these values. So, for example, in 1A, if we number the x-coordinate of each one of these in a ranking of how they occur from left to right, it would just be 1, 2, 3, 4, 5, 6, 7, right? If we did similarly with the y value of each one, you can see that actually it would also be 1, 2, 3, 4, 5, 6, 7, right? So in this particular case, we have, again, perfect positive correlation because they're in the exact order from the x point of view and from the y point of view. Let's try to do the same thing with the B graph. So in this one here, I think there's a tie, or actually there's a tie in the y direction, but in the x direction it's pretty clear that they just go up from 1, 2, 3, 4, 5, 6, 7, 8. Do you notice that 7 and 8 are basically 8 is slightly to the right of 7. Okay, and if you look at from the y point of view, it's kind of hard to tell. It looks like 1 and 2 might be tied. So if 1 and 2 are tied, I would put a number between 1 and 2, 1.5, for the first two, for the ranking, because they're kind of tied between first and second place, right? And then I can start numbering them from 3 through 8, right? Now, in the back of the book, it said that it considered the red dots one slightly above the other, but it doesn't look like that to me. So if I was going to assume that the first two dots are the same height, I would rank the first two dots 1.5, right? So if I'm going to put this data in there, I would put the red data into the first column. So I'm going to put the numbers from 1 through 8 in the first column in order. And then in the second column, I am going to put the numbers from 1.5, 1.5. So I'm going to put 1.5 in the first one, 1.5 in the second one, and then I'm going to start going 3, 4, 5, 6, 7, 8, and then we'll see what we'll get, okay? We'll probably get something really close to 1, but it won't be 1, right? So then we'll go to MAIlinreg, and we'll put list 1 and list 2. And our R value is 0.994. So I'll put that our R value is 0.994. Does it ask us to comment on it? No, it just says to write down the correlation coefficient. So the first one would give me R equals 1 because it's perfect, right? What about the second one? So in this one here, I would number the X values in order, right? And the Y values would actually be in the reverse order because it's decreasing, okay? So because one of them is increasing, the other one is decreasing, if we graphed it, we would graph like 1, 6, 2, 5, 3, 4, 4, 3, 2, 5, 2, 6, 1. So it would be a line with negative perfect correlation. So it would be R equals -1, right? Because they go in the opposite order. One goes in the opposite order of the other. Let's look at D. Now D is kind of a mess. So again, for X coordinates, you could say, okay, I'm going to number them in order. And then for the Y coordinate, we have the smallest one here. Here we have a tie for second and third. Next one, we have a tie for fourth and fifth. And the last one, we have a tie for 6 and 7. So we'll put 6.5 for both of those. So let's see what kind of values we get for that. So we'll do stat edit again, and we'll number the first column from 1 through 7, because we'll have 1 through 7 on the first column for the red numbers. And then in the second column, we're going to have a pretty weird order here. So 1 corresponds to 6.5. 2 corresponds to 4.5. 3 corresponds to 2.5. 1 corresponds to, red 4 corresponds to blue 1. Red 5 corresponds to blue 2.5. 6 corresponds to blue 4.5. And red 7 corresponds to blue 6.5. And then the last one, there is none. Okay? And then I'm going to do stat calc linreg for this. And we'll see what my R value is for this. It is 0. Interesting. Okay, so there is no tendency here for regression, or for a linear regression of the rankings, or Spearman's correlation coefficient is 0 in this case. Okay, All right, let's do number 2. A group of students is asked to rank 6 snack foods by taste and value for money. The ranks are averaged and recorded in the following table. Calculate the Spearman's rank correlation coefficient for the data and comment on your results. Okay, so as a first step, I have put in my data 2, 5, 4, 3, 1, 2, 5, 4, 3, 1 into the calculator, and then I'm just going to do stat MAIlinreg, which is number 4, and then I'm going to see what my R value is. And my R value is 0.2. So if I was to comment on this R value of 0.2, remember back to what we learned about linear regression, I would say this is a positive, very weak correlation, right? Between 0 and 2.25, we should say it's very weak. Okay, it's not linear though because we're just doing the ranking, right? Okay, let's look at number 3. Find the Spearman's rank correlation coefficient for the following data sets. So first thing I need to do here, since these aren't ranks, these are actual data, we need to order the data according to smaller to larger, or larger to smaller. Either way is fine as long as you're consistent. So in this one here, look at this. The smallest number is 7, but there's 3 of them. So we're kind of averaging rank 1, rank 2, and rank 3. First, second, and third place, we're averaging them. So we should rank them all 2, which is the middle number. Okay? Then 9 would be 4, 5, 6, and 7. Okay, and then we're going to input 1, 7, 2, 6, 3, 5 into the calculator, and I'll do that offline so I don't bore you. So there you go, and just a hint, to clear all the data in list 1 or list 2, just use the button clear, don't use delete. So now all we need to do is do stat MAIlinreg, and go to calculate, and then we should check the R value here. And make sure you check R and not R squared, okay? R here is R equals negative 0.963, so it should be R equals negative 0.963. So, it's 964 actually if we round correctly, right? We should use 3 significant figures as usual. And here I would say that the correlation is negative and strong, right? Because 0.964 is very close to 1. Okay? Let's do the next one. So in the next one, we're going to, first of all, we're going to rank the X data. And I like doing smallest to largest because that's usually the way we count, right? But oops, that's wrong, right? Because the next one is 8. 3, 4, 5, 6, 7. Let's do blue. This is the smallest. 4, 5, 6, 7. Okay. And then we'll just go to stat edit and input this data again. And just to show you how to clear this data, you just go up there and you press clear. And then you hit enter, or you go down. So it's pretty easy to clear the data, just don't delete the list. Okay, and then I'm going to do the data input offline so I don't bore you. Data, and now I'm just going to do stat MAIlinreg. See what R value I get again. So the R value in this case is 0.893 if I round to 3 significant figures. That's also a strong value, and this is in the case it's a positive strong value, right? Okay, and that's it for this page.